Hello, my name is Hanno Van Raalte. I'm product manager for Moldflow, and I'm talking to you today about the Moldflow 2021 release. So I'm going to cover a number of things today. I'm going to go through the security hardening we've spent a lot of time on this year, explain a little bit about the background behind it and what we did. I'm also going to talk to you extensively about a new simulation compute manager, which is the new replacement for the job manager. I'm going to go through a number of software updates and new capabilities there, as well as some software changes or other changes. But before that, I wanted this do a bit of a level set on what we are attempting to do for like Moldflow in the current era, but also like preparing ourselves for what's coming. So Moldflow Synergy, as we've known for a long time, is actually almost 20 years old now. If you think about 20 years back, this was a what we thought about as a computer. The phone next to it was basically what we could declare a sort of a state-of-the-art phone. And many things have changed over the years, right? So what we consider a powerful computer 20 years ago and what now powerful computers are, those are completely different things, right? So, and also when we think about like things like clouds are now almost an essential piece of what we do like, as a person individually. We are um, doing online banking, and we are now, let's say, even at work, using things like Microsoft Teams to collaborate with others on a cloud platform. But also like things like what a computer is like is completely different now. Like you can see this over here is uh, a laptop, and like that's I mean, a lot of our are working on laptops nowadays, and also like things like tablets are uh, is a completely new thing. They're really good consumption devices, but also like things like what a we consider now a phone is different from what we considered like 20 years ago, and all those things actually are now becoming slowly part of the compute ecosystem. So things that we have to deal with over the next years is like um, how do we provide workflows where the interactions that we have with computing is no longer actually just from a static terminal, but it could be from anywhere on any kind of device. So, and those things are like now have changed drastically, right? So even like right now, if you think about it, 5 years ago, even a year ago, sort of what we considered work was the office. Now we're in COVID era, and like many of us work from home now, and that's become sort of the norm. My kids go to school like now with online, and it's that's becoming sort of standard now, right? So our lives have changed around the pandemic, but like these things are going to be permanently with us for a while because we are adapting to it, and we're going to see what the benefits of these technology adaptations are going to bring to us going forward. So a lot of these trends will expect to be with us for a while. Like what we expect in the next years is like data is going to be more and more in the center. And when we think about data, it's not just the CAD model, for instance. It is not just the simulation data we were talking about, but also the things like uh, end user data or production data or experimental data. That all become part of what we consider to be data that is relevant to the product, if you will. And these things are going to help us to create better insights and actually do more important things in a timely manner. So, and all the data also has to be accessible for anywhere, right? So it's not just you having a portal into this data. We expect over the years that this data will be shared with collaborators, your team members, but also to allow others outside of your direct company ecosystem, like providers or suppliers, to be able to access to their components that they're working on with you. So all this data, like I said, there's going to be more of it. It's going to be more it's going to be richer, and it's going to have to be accessible from anywhere. And all that also is going to allow us to we create insights and build more informed decisions. So we see a lot more, expect to see a lot more use of technology like artificial intelligence or machine learning to make sense of a lot of data, but also see if we can actually streamline workflows a lot more. We've seen over the last couple of years even a lot more workflow automations to help sort of pretty menial tasks to become sort of more streamlined and quick to do, and we should expect that a lot more going forward. Also, things like automation, optimization, we see a lot more to get to better answers quicker, if you will. So, if you think about it, like 10 years ago, you would run a bunch of analysis and get to a good enough state, because that was the only practical way to get to a successful completion. With the much more widely available compute power and progress in availability of compute power, we should expect optimization to become a much more widely available tool to get to the best solution or a much better solution in a shorter amount of time. So we already have seen really good examples in the Moldflow community of use of things like DOE to save time, and we expect that to be a continuing trend. I already touched upon compute power. Like we expect a lot more raw compute power to be available, and also to have the interaction with compute power to be different. So, for instance, my daughter right now is going to school, like I said, and she's using a Chromebook, and the expectation is that whatever you do in a Chromebook is going to be exactly the same way as what you have on your high powered desktop computer or even your powerful laptop. So even though that's Chromebook is maybe $100 and a much lower spec machine than and sort of most of our what we mostly used to at work, the expectation is that these things are still going to be working correctly and performing equally well as sort of the high-end hardware. So we expect all those things to become continuing trends, and also things like you expect things like tablets to become a larger play in how we access technology and do useful things there. So as part of this, so in the next couple of slides, I'm going to talk about some things that are really instrumental of moving us forward to sort of the next stage in what we expect to be in the next couple of years. So we spent a lot of time this year and made a very, very deep investment in the last 2 years, I want to say, in changing the way we develop products, as well as making data security an essential part of how we develop products right now. That's not just in Moldflow, the Moldflow development team, but also across the board in Autodesk. We have now an extensive data security team that helps us not only just monitor what's happening in the world of best practices from a data security perspective or like data security threats that might be out there, but to teach us as an organization on how one should approach code development in a secure way. So that involves things like including automatic code scanning. So every day before anything gets checked in, you go through a scan to look at like, hey, are there ways that it's coded up that could allow a hacker, let's say, to penetrate the code and take advantage of an area. that's now part of our like standard way of developing code, and it took a long time for us to work through all our lines of code. If you will, like Moldflow is a 30 to 40 year as a code base that's 30 to 40 years old, and it was never intended to actually to with this in mind, if you will. So we had to fix a lot of those small coding errors that and make sure these are buttoned up and watertight, and also upgrade a lot of components. So we had a number of components that were had been there for a while, and as part of this security team mandate, we actually are now required to have certain levels of components in our software. So to make sure that these are certified and actually used within the organization, not just our version, but other softwares and others may actually use the same component, but this is a certified version of um, this component that we are allowed to use because we know as a company this is a secure piece of code, and we've validated that. So all in all, like we spent a lot of time um, in beefing up security, hardening the code effectively, and it's all with in mind like to if remote computing, cloud, all those things become uh, an integral part of our future, then you're gonna have to you're gonna require us to actually do our job and make sure that whatever you send us to the cloud, if you will, is secure. So as a cloud provider and a cloud service provider, it is up to us to make sure that whatever data you give us is trusted in our as trusted in our ecosystem as it is in yours. So you, as a company, have your own security policies in place. We have ours, obviously, but like we have to make sure that we your data is as secure in your environment as it is in our environment, right? So that is going to be clearly something we have to get ready for, and then make sure that that's an understood and completely ingrained thing in the way we develop products. So a second big investment we made was in the simulation compute manager, and this has been in the works for a couple of years now, and it is basically based on a highly secure and modern architecture. So it's like from the ground up, we've learned a lot of lessons from the old SJM, sort of simulation job manager, where we had a number of things in the code that were homegrown and developed internally, and now we actually are using commonly used components for, let's say, data transfer, and we've had an extensive beta program that we just finished, and it's been actually very successful in the way the reliability of the SCM is very high right now. So we're very confident if you submit a job and it completes, the data comes back to your local machine. So, and that was always a struggle point for the old job manager, where in certain occasions, like the connections were lost and we would not be able to recover from it. We have actually, now with SCM in the beta, seen that we actually have been very successful in getting our data back once it's submitted, right? So it's a state of the art cloud backend. We have also developed on the cloud, so it's a new cloud backend too. It's all Linux based, so it's a bit more efficient in that sense than the Windows platform. And if you're using Linux, or occasionally had questions from some of your users like, hey, but how invested are you guys in Linux? How important is it to you guys? And then tell you now, like, it is our own cloud backend is Linux based, and it's so if we're invested in making our clouds efficient, this is certainly now a part of like part of our ecosystem that's there, increasingly there to stay. Another thing that's important to point out is that it has a new cloud queue-driven workflow. So it is it's set up in a way that you can actually now set up a distribution queue for not only yourself, but like say your colleagues. That can be one queue manager, and you can actually point a number of computers to that queue manager to actually work through these jobs efficiently. So this is like I said, it's similar to what an HPC concept, if you will, like where you have, let's say, a cluster where there's a centralized node that's there to submit and distribute work. The new batch queue-driven workflow is sort of in a similar has a similar idea where there's a centralized queue where you can submit jobs to, and other machines can pick the work up. You can still like actually submit your job to your local machine or directly to another machine's queue. That still hasn't gone away, but like the architecture is such that you can also like set up a centralized queue where you and your colleagues can submit your work to. I have a couple of videos for this. So this is a short video of the basic workflow. I have a model open over here, and I'm signed in the cloud right now. I do not have to be. If you don't want to use the cloud, that's fine. But if you are submitting to the job to the cloud, then you need to be signed in. This is the new job launcher windows. I can submit to the cloud over here. I can see the cost associated with it, or I can submit to my local machine. I can also add a new machine to submit other jobs to. So I could, let's say, I'm adding over here my my small laptop as a job server, and now have a queue that I can submit to, or I can submit to my local machine. I'm going to submit my work to my local machine over here. I can run a check analysis only or launch, and I can specify my default, so you don't have to switch at this point. Another video is for the SCM Viewer, so the new viewer for Simulation Compute Manager. So I have the same model opening and it's running right now. And now I can look at my job queue or my remote job queue. And it opens up a new browser. And so this is the new sort of the new job viewer is actually browser based. So it's using your default browser. In my case, I use Chrome, and you can see over here I can specify. I have my machine name specified. You can see the sequence. I can view the log itself. I can so even if I actually do not need to actually have Synergy installed for my machine, I can actually just view the job queue from any the progress of my jobs from any machine, as long as it has a browser and can see my machine. There's a number of filters you can set. You can specify like who runs the analysis, or how long back I view my queue. I can look at all jobs that are running, or I can use my cloud. I can log in there to see what's running on my cloud, which I didn't do over here. I can add sort of jobs that finished, and then I can filter status on the last modified. And I can do the same thing actually for my remote machine. So this is again going to open up the browser tab with now my little machine as sort of the server. So this is my old machine, my local machine, and this is the queue on my uh, small machine. So this was running on that particular machine. So another little video of how to add your how to create add your machine to another machine's queue. So one thing I can do is if I go to Simulation Compute Manager, I can now add my computer to serve a to run jobs from another queue. So where in the past you had uh, your you would push your job from your local machine to another machine. In this particular case, I can add my machine to serve another queue. So if anything comes up in the other machine's queue, my machine is not running anything and has a license available, I can actually pull the job down to my local machine automatically and run the job. So I can actually have, let's say, for one queue, I can set up 4 or 5 different workers that can serve that queue. And let's say all my 5 colleagues can submit all their jobs to that one centralized queue. So that really allow you to run go through a lot of work very quickly. Another little video to show how I can sort of limit the number of jobs my machine runs. So I do not want to, let's say, run 10 jobs on my machine at the same time because that will lock up my local laptop. And if you go to the job viewer, there's a job limits setup. I can set it to 2, for instance. And when I now submit all these jobs at the same time, I can go to Analyze. I can submit it to the cloud. You can see like how many cloud credits that whole bunch of jobs would take, or I can submit it to my local machine, which I do. And when I go now to the job manager, and I'll remove the ended job. So I can see now there's 2 analyses running at the same time, and 2 are pending. Pending basically means that waiting for room on machine to become available, because I restricted the number of simultaneous analyses to be 2. So, all right, so that's ends sort of the little demos of the new job manager. I hope this is going to be helpful for you guys. So now we're going to go through this next section is going to be the solver updates and new capabilities there. So a big improvement we made this year is the ability to predict sync marks. So we all know that for sync marks in the back in the days, or until now, we needed to we could only predict sync marks on the sort of the back of what we could consider a rib, and a rib is actually pretty narrowly defined. In reality, you can actually have, let's say, very wide areas that have thickness increases, and a sort of a wide rib or a wide shallow rib, and we'd not actually be able to actually predict any of the sync marks on that, even though clearly they would be prime candidates for getting sync marks. So in the 2021 release, we actually now have ability to predict sync marks on narrow, thin areas as well. So we have a much better chance of actually catching the entire all the sync marks that are occurring. So a much improved experience is available for both the Insight and Advisor. Another thing we added this year is the ability to display certain color plots in with different legends, if you will. And this is like, it has a couple of different use cases. One of them is like if you're colorblind and let's say certain colors are not easily identifiable as others, then maybe some of the new the color bars allow you to get better insights or give you better contrast in what's actually happening. Another way is to look at certain data in ways that are much closer to what you actually normally observe experimentally. In some cases, let's say you look at thermal scanner data in certain uh, legend, and in Moldflow we actually always had the blue, green, red rainbow plot, but it's hard to compare that sometimes to other experimental data, let's say thermal scanners. I'll give you a couple of examples of how this could be useful. In this particular case, I have an example of how we could use this as a sort of an estimate on how visible certain flow marks would be if you were to have a polymer with metal flakes. So the metal, we know that like the orientation of metal flakes on the skin will actually have a massive influence on how the reflectivity or the appearance of these um, metallically pigmented polymers, and at the weld lines, the orientation of that the metal flakes will be perpendicular to the skin, and therefore you actually not see the reflective effects that you're hoping for, and then you get these black streak lines or markers. So in this particular case, I run a fiber orientation on a flake filled plastic, and look at the fiber rotation tensor in a contour plot instead of the tensor plot, and then changed it to grayscale. And with that, I can now have a fairly decent estimate on which of these flow marks are going to be visible and not. So this is may not be 100% perfect, but it's going to give you a pretty good idea, sort of how this could manifest itself. And it's definitely easier to interpret than than just looking at the fiber orientation tensors themselves. So I hope you can find this useful. Another area where this could be useful is, let's say, in the birefringence plot. In many cases, like it was hard to correlate our rainbow plot with the experimentally observed color plots, and it is this now in a grayscale, for instance, would be a much easier way to compare one-to-one with experimental data. Another big improvement, and this is a non-default option for Moldflow Insight, and an advisor is going to have the same ability, by the way, is the default packing profile. So an automatic packing profile. It's not a default. Default is still our old 10 seconds, 80% of maximum injection pressure, but we know for a fact that this default packing pressure is in many cases too long or too short to have an accurate representation of reality. But in many cases, the user or will not actually have an idea what it actually is going to be, what's going to be appropriate in reality. So so we now have an automatic packing profile as a non-default option, where we actually looking at the model and compare the available pressure as well as available clamp force on a machine, and see how much pressure we can actually exert on the user to basically calibrate the injection pressure on this, as well as on the duration side, monitoring during the packing itself, like if the flow rate goes certain close to zero, then we will stop there's no point continuing packing, right? So during the packing profile, we're continuing to monitor like how much flow rate there is still in the part, and if there's like almost no flow rate happening anymore, then that we've reached the end of packing, and we can stop it and switch to the cooling time. So like I said, this is still a non-default option, and it's the effects might still be sort of different from significantly different from the default behavior, because now we are basically trying to minimize the amount of shrinkage the part is going to experience. And like in some cases, like I said, it's the old job might actually the old default packing profile might be doing a reasonable job, but this hopefully is going to get us in a much closer, more realistic range by default. So we're eager to hear back on this topic from you guys. Another big improvement this year is in that we are changing the way we treat semi-crystalline materials in the 3D flow solver. So we had certain kind of behavior in the dual domain solver for a very long time already, in the mid-plane as well. So that's treatment of like how plastics solidify, semi-crystalline materials solidify. We've had this behavior in the mid-plane dual domain solver for a long time, and now actually adding that same behavior in the 3D code. And we expect that to across the board to give us more shrinkage than before, as well as an improved warpage prediction. So so it does not require any new material data. This is all based on the existing material data that you already have. So there's no new algorithmic improvement there, particularly for crystallization that requires new material data. So this is just using the data you already have. Another big improvement is the way we treat insert contact. Before until now, we actually, if you had multiple inserts that were touching, inserts would be moving independently of each other, even though in reality they would actually be touching. So when they're touching, you can not actually move into each other's space. So in the new solver, we actually are like connected inserts, even though they're different material, are now sort of glued together, and they will respond as sort of a single body with possibly different material properties. But like it's so they're stuck together, and they will be continues to stick together. There's a whole lot of other smaller solver improvements in place. We made some improvement in the mechanical property calculation in a couple of places. Some minor changes in the midplane and dual domain changes that we made already before in the 3D solver, but because of time constraints with respect to running crimp-tree correlation, we did not actually do them last year. For the midplane and dual domain code, that actually was a very small minor change that almost not, we should not expect a tremendous amount of impact on that particularly, but it brings the two codes in line. Also for some improved behavior on the mechanical property calculation for fiber-filled and disc-filled polymers. On the 3D flow side, we have some new improved well surface prediction. So in the past, we had sometimes like some holes falling into weld surfaces that we were predicting, and now we're doing a much better job in creating a continuous what surface field, if you will. We also made some improvements in the what happens when, let's say, a valve gate opens. So we have now smaller time steps around in the internal solver around the time where the valve gate opens, which should help reduce some of the anomalies that you could see with the solver sometimes on when the valve gates open. We also made some improvements in the 3D core shift accuracy, as well as on the microcellular foaming prediction, particularly better structure and mechanical properties to be taken into account in warp. On the midplane and dual domain side, we actually had some improvement on the barrel compressibility, and we now are writing out profiled results by default. So many of you may or may not notice, but you if you wanted to look at temperature through the thickness and at every layer, you had to switch on or write profiled results to make that happen. And it basically means, like, in some cases, if you wanted to look at results that were not written out by default, you had to rerun the analysis. So now we actually are running those results by default. That has as a consequence, though, that like the amount of data we're producing now on a midplane and dual domain flow analysis is going to be significantly higher, because now we actually capture a lot of detailed data through the thickness at every time step. So there's a lot of data we creating there, but like it's going to be, you're going to have much better insights and be able to diagnose things a lot better. We also made some really good improvements on the cool BEM solver. That's the old cool solver, where we have now, in some cases, a much better solution stability, particularly areas where, let's say, you have a cooling channel close to a mold wall or part, where sometimes it could lead to divergence. We actually have now a much more stable solution, and that's resolved already a couple of support cases that we've gotten over the last couple of weeks. So on the solver API side, we're now it's now available on Inside Standard, Premium, and Ultimate subscription level. So in the past it was only available on the Inside Ultimate subscriptions, but now it's available for all levels. And then we have sort of new solver API functions for exposing or like getting access to field data that you can build on top of, as well as some new fiber orientation components, if you will. So you can actually now, if there's things in fiber orientation that, or effects that you would like to build on top of that are not part of, say, the standard flow code and fiber orientation code, you can now actually build your own module on top of that, if you will. So as well as like some new ways to interact directly with the accuracy of the solver, let's say in terms of time step control. So in addition to that, you also have for the 3D buckling analysis now a meshing aggregation on that makes the 3D buckling analysis about 10 times faster and makes it use a lot less memory. And that makes it a lot more practical to run. In many cases, like for large models, buckling analysis can take an enormous amount of time and use a lot of memory, which makes it really impractical. And now with these the mesh aggregation on, it becomes an actual viable option for fairly large models to run. So it's still like a very large analysis, so we're not going to be switching it on for every small deflection analysis, if you will, because it would still, the buckling analysis would take longer than the small deflection analysis. So it would not make sense to have an automatic setting that we have in the midplane the midplane world, where we run a buckling analysis first, and then depending on the results, either go for a large deflection or a small deflection. That's still the buckling analysis will still run for a long time, so it is not practical in that sense, but it is still a lot faster and more viable to run than before. So that's good. So as a new option, we actually brought in sort of the polyurethane foaming analysis, and there's two variations of this represented by these two images. So in the Moldflow and we now have like so injected foam. We continue to inject the resin, and the resin will expand and foam out the cavity. So at some point we'll actually stop injecting, typically around 10% of cavity filling, and the rest will basically be filled by the foaming action. Or you can basically specify a location where it's like, hey, so these elements over here are the beginning filled with foam, and now the foaming reaction will start and will fill out the cavity. So either through an injection or an initial charge, you can start the foaming. Some other changes. So we have now upgraded our CAD translators to these particular versions. It wants to call out our, let's say, Creo Parametric 7.0, new CATIA versions, as well as SolidWorks. And we have upgraded our material database right now. We are close to 1150 materials in the database, so it's the database is growing. We're still testing materials in our lab in Melbourne, or as well as our partner lab in Penset Erie at Beaumont Technology. So both are still testing our continue to test materials and creating new data. So database is growing, and it's getting better and then improving in quality. So with that, I'm at the end of my presentation. I hope you enjoyed the 2021 release, and thank you for your attention.